This is a neuron. First you see the soma, which is the body of the neuron, and then you see the axon hillock, in which the graded potentials are summed and the action potential is formed. Then you see the axon, which is made up of myelin sheath cells and the nodes of Ranvier. Two helper cells are going to be what myelinate the axon. It's going to be Schwann cells and oligodendrites. These are also known as neuroglial cells. In the central nervous system, the axon is myelinated by oligodendrite cells. In the peripheral nervous system, the axon is myelinated by Schwann cells. Because myelin makes it difficult for ions to move throughout the axon, the nodes of Ranvier are there for the action potential to move from node to node. For an action potential to move down an unmyelinated axon, it's going to be using continuous conduction. The first step in this process is the action potential developing at segment 1. This causes the membrane potential at segment 1 to depolarize to 30 millivolts. The second step is when sodium enters at section 1, it moves away from the voltage-gated sodium channel and enters towards the second section, causing the second section to meet threshold. The voltage-gated sodium channels open quickly when the threshold is reached and allow for sodium to rush into the cell. The potassium channels open when the threshold is reached as well, but the potassium channels open slower. At the third step, the section 1 begins to repolarize as the action potential happens in section 2. At the fourth step, the sodium ions enter section 3 and are spread laterally. The section 3 membrane is brought to threshold and the process is repeated. For myelinated axons, the action potential is moved via saltatory conduction. Because the myelin makes it hard for the ions to move across the membrane, the action potential must hop across from node to node. The second step is local currents producing a graded depolarization, bringing the membrane of the following node to threshold. For step 3, the action potential is developed at node 2. The fourth step is the process repeating at each node until the action potential has reached the terminal end of the axon.